Hello everyone, welcome to solve this math Olympiad algebra problem, and here we have 8 to the power of m plus 2 to the power of m equals to 130, and we solve this problem for the values of m. So now the very first thing we are going to do is, now first we convert this exponential equation into the cubic form, so that here we first make the prime factors of 8, and we know that its prime factors are 2 to the power of 3 and its whole power m, plus we write this as 2 to the power of m equals to 130. And now in the next step, here we need an exponential law, and we know about this law. If we have a to the power of m to the power of n, it is equals to a to the power of n to the power of m. It means that if we interchange these two exponents, it cannot be affected our final answer, so that here we just interchange these two exponents, and it will be written as 2 to the power of m and its whole cubed plus 2 to the power of m equals to 130. And now in the next step, here we take 2 to the power of m equals to y, so we write it here, y equals to 2 to the power of m. Then our above equation will be written as in this form, y cubed plus y equals to 130. So now this equation will becomes in cubic form, so here we write in standard form. So we move this 130 in the left hand side, so it will be written as y cubed plus y minus 130 equals to 0. So this is cubic equation. So now here we need to make the factors of this cubic equation, or we have another method which is known as synthetic division. So you can choose any one of the method to solve this problem. So here we can easily make the factors of this equation. So now first we focus on this minus 130, and we write this minus 130 as minus 125 minus 5 equals to 0. And after that, here we write this equation as y cubed plus y minus, we write this 125 as 5 cubed minus 5 equals to 0. So here we make the pair of cubic terms and the other term. So we have the cubic term is y cubed and 5 cubed, so it will be written as y cubed minus 5 cubed plus the other terms are y minus 5 equals to 0. So now here we focus on this cubic equation, and here we use the nice cubic formula. You know about this formula. If we have a cubed minus b cubed, it is equals to a minus b times of a square plus ab plus b square. So here we use this nice cubic formula, and we use this formula on this factor only. So here you see that we have the value of a is y and the value of b is 5. So we substitute a equals to y and b equals to 5 in this equation. So when we substitute these two equations here, then it will be written as a minus b. So we have y minus 5 into, we have a square, so here our a is y, so it becomes y square, and ab, so a is b is 5 and a is y, so we write it as 5y plus b square, so b is 5 square, and plus y minus 5 equals to 0. So in the next step, here you see that we have y minus 5 be the common factor. You see here this and this, so we take common y minus 5, and the remaining terms are y square plus 5y plus, here you have 5 square becomes 25, and we take common y minus 5, and here we get plus 1 equals to 0. So here we little bit simplify this equation, and we have y minus 5 times of y square plus 5y plus 26 equals to 0. So here we have two cases. The first case is we write y minus 5 equals to 0, and the second case is we write y squared plus 5y plus 26 equals to 0. So here we have the value of y equals to 5, and now here we have, this is the first real root of this question, and now we check is this quadratic equation has a real root or not, because here we need only real root to solve this problem. So here first we check this equation has real roots by using the discriminant formula, and first we write the coefficients of this equation, and its coefficients are a equals to 1, b equals to 5, and c equals to 26. So we have the quadratic formula is the discriminant formula is denoted by delta equals to b square minus 4 times of ac. So here we substitute the values of a, b and c, and we have the value of b is 5 square minus 4 times of a is 1 and c is 26. So we get here 25 minus 4 times of 26 equals to 104, and when you subtract these two values then you get here minus 79. So you see here our delta is less than 0. So if our delta is less than 0, it means that this quadratic equation has no real root. So if it has no real roots, then we rejected this case and we can just proceed here this case only, and in this case we have the value of y is equals to 5, and now we back substitute the value of y, and we know that our y equals to 2 to the power of m, and here we back substitute this value of y. So this implies that 2 to the power of m equals to 5. So because here we solve this problem for the values of m, so now we take log on both of the sides, and it will be written as log of 2 to the power of m equals to log 5. So here we use the property of log, and we move this exponent in the front of this log, and it will be written as m times of log 2 equals to log 5. And now we move this log 2 to the right hand side, and it will becomes m equals to log of 5 divided by log of 2. So here we use the calculator or logarithmic table in order to find the value of these logs. So we easily find the value of log 5 is equals to 0.699, and the value of log 2 is 0.301. And now we divide these two values, and we easily get the value of m equals to 2.32. So this is approximate value of m, and this is our final answer. And now we check this solution. Is this solution satisfied our given question statement or not? So to check this, here we first copy down the question statement, and our question statement is 8 to the power of m plus 2 to the power of m equals to 130. And now we substitute m equals to 2.32. So this will becomes 8 to the power of 2.32 plus 2 to the power of 2.32 equals to 130. So here we check is this equals to 130 or not. So if if you take this power of 8, then we get here 125.01, and plus we take the power of this, it is equals to 5.00 equals to 130. So when you add these two values, so it is approximately equals to 130 is equals to 130. So this shows that m equals to 2.32 satisfied our given question statement, and this is the final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.